In this lesson, we will be finding factors. We're going to be modeling factors, learning about divisibility in factors, and talking about common factors. Let's use a model to find all the factors of 8. To model, if 1 is a factor of 8, we can show one row of 8. One is a factor of 8. Let's determine if 2 is a factor of 8. If 2 is a factor of 8, 8 must be divisible by 2. We're going to model 8 divided into 2 rows. 1, 2, 3, 4, 5, 6, 7, 8. 8 divides evenly into 2 rows. 2 times 4 equals 8. So 2 is a factor of 8. Now let's look at 3. Is 3 a factor of 8? We can ask ourselves, is 8 divisible by 3? We're going to divide 8 into 3 rows. 1, 2, 3, 4, 5, 6, 7, 8. We have 2 left over. So 3 is not a factor of 8. Let's look at 4. Is 4 a factor of 8? Or we can think, is 8 divisible by 4? So we're going to make 4 rows and divide our 8. 1, 2, 3, 4, 5, 6, 7, 8. We have 4 rows of 2. 4 times 2 is 8. So yes, 4 is a factor of 8. Let's continue on. Is 5 a factor of 8? I'm going to make 5 rows and divide my 8. We have 3 left over, so 5 is not a factor of 8. Let's model to see if 6 is a factor of 8. We'll make 6 rows. There are 2 left over, so 6 is not a factor of 8. 8 is not divisible by 6. Let's see if 7 is a factor. First, let's model. We made 7 rows. We have 1 left over. So 7 is not a factor of 8. Is 8 a factor of 8? We'll make 8 rows with 1 in each row. 8 times 1 is 8. So yes, 8 is a factor of 8. So the factors of 8 are 1, 2, 4, and 8. Every whole number greater than 1 has at least 2 factors, that number itself and 1. Now let's take a look at divisibility rules. A number is divisible by another number if it can divide evenly with no remainder. The divisibility rules can be used to decide if a number is divisible by 2, 3, 5, 6, or 9. Let's use the number 12 as an example. Let's see if 12 is divisible by 2. The rule is the last digit must be even. So the last digit of our number 12 is 2. Is 2 an even number? Yes, it is. So 12 is divisible by 2. Let's look at the divisibility rule for dividing by 3. 12 divided by 3. The sum of the digits must be divisible by 3. So in our example, the number 12, the two digits are 1 and 2. The sum of the digits, 1 plus 2, is equal to 3. We have to ask ourselves, is 3 divisible by 3? Well, 3 divided by 3 equals 1. So yes, 3 is divisible by 3. So 12 divided by 3, 12 is divisible by 3. Now let's look at 12 divided by 5. The rule is the last digit, in our example, the last digit is 2, must be a 0 or 5. Well, the digit 2 is not 0 or 5, so 12 is not divisible by 5. Let's look at our divisibility rule for dividing by 6. The number must be divisible by 2 and 3. So the number 12 must be divisible by 2 and 3. Well, we've already determined that 12 is divisible by 2 and 12 is divisible by 3. So 12 is divisible by 6 as well. Let's look at the rule for dividing by 9. The sum of the digits, remember the digits are 1 and 2 to make 12, and the sum, 1 plus 2 is 3. So the sum of my digits must be divisible by 9. 3 is not divisible by 9, so 12 is not divisible by 9. Let's use the divisibility rule for 3 to determine if 3 is a factor of each of these numbers. First, let's look at the number 42. Remember our rule. The sum of the digits must be divisible by 3. So we have the digit 4 and the digit 2. When we add these two digits together, we get 6. Is 6 divisible by 3? Well, I know that 6 divided by 3 equals 2. So yes, 42 is divisible by 3. Now let's look at 56. Let's add our two digits. 5 plus 6 is equal to 11. Let's see if 11 is divisible by 3. 11 divided by 3. This does not give me an even number. 11 is not divisible by 3. So I know that 56 is not divisible by 3. Now let's practice finding common factors. I've listed the factors of 8 and the factors of 12. A common factor is a factor that both of those numbers share. So using this table, I can see that 2 is a factor shared by 8 and 12. I can also see that 4 is a common factor shared by 8 and 12. We can use common factors to help us solve problems. Take a look at this problem. Claire is making goodie bags for her party guests. She has 12 candies, 16 bracelets, and 20 stickers. Each bag will have the same number of items, and all items in a bag will be the same. How many items can Claire put in the goodie bags? To solve this problem, we need to find the common factors of 12, 16, and 20. Let's list the factors of 12. I know that 1 times 12 is 12, so 1 and 12 are factors of 12. I can multiply 3 times 4 to get 12, so 3 and 4 are factors of 12. And I can also multiply 6 times 2 to get 12. So 6 and 2 are factors of 12. When I find the factors of 16, I'll start by, I know that 1 times 16 is 16. I know that 4 times 4 is 16, so 4 is a factor of 16. And I know that 8 times 2 is 16. So 8 and 2 are factors of 16. Now let's find the factors of 20. know that 1 times 20 makes 20, 10 times 2, and 5 times 4. So now that I've listed all the factors, I need to find the common factors, the factors that are shared between the numbers. The first common factor that I see is 2. 12, 16, and 20 all have the factor 2. The next common factor I see is 4. And finally, the last common factor is 1. So Claire can put 1, 2, or 4 items in each bag. And this concludes our lesson on finding factors.